In the following slides, we will present you two options that can be added to Swissbit memory modules. These add-ons will extend the usability under critical environmental conditions. Swissbit addresses, with its industrial DRAM modules, the often harsh and extreme environmental conditions that occur in the embedded industry. Systems and memory modules may be operated in Arctic regions, where temperatures are in the very low range. On the other extreme, you will find automation and process control systems with memory modules in industrial environments like steel plants or other locations, where the module is exposed to highest temperatures. Industrial memory modules also work in transportation applications, where in addition to temperature changes, vibrations and shock stress the modules. Robustness is one of the many requirements for this industry. Last but not least, memory modules can be found in environments where aggressive gas or high humidity cause corrosion of unprotected electronic components. Swissbit offers conformal coating of their modules to guarantee a long lifetime even under such unfriendly environmental conditions. DRAM cells are very sensitive to high temperatures. The cell's charge is quickly dissipated at high temperatures, and the information is lost. This is why DRAM components are quite limited in the operation temperature range. The normal DRAM spec allows a case temperature from 0 to 85 degrees Celsius. If the environmental conditions require that the module withstands lower or higher temperatures, Swissbit offers modules that can operate reliably between -40 and 95 degrees centigrade. Swissbit tests each individual of those modules at both low and high temperature corners in order to guarantee a reliable function. The case temperature of the DRAM package depends very much on the heat dissipation through the module PCB, the socket, and the surrounding air. Air is a good thermal isolator if you don't have any airflow, a condition that occurs quite often in fanless embedded systems. Unfortunately, today's DRAM chips have very small die sizes, often much smaller than the actual package. The right picture shows the real size of the physical die in relation to the complete module. All of the generated heat generated by the DRAM dies is concentrated within a few square millimeters, as you can see on the left side, which shows an infrared capture of DDR2 SODIMM under operation. These hotspots are most critical for the retention time, the time that components keep the stored information. In most cases, where even modules with the extended temperature grade are not sufficient for the environmental conditions, adding a heat spreader to the module is the last step to avoid data loss. The heat spreader dissipates the heat away from the hotspots and levels out the temperature distribution. The Swissbit heat spreader reduces the hotspot temperature by some degrees Celsius, which translates into higher data reliability and protection against data loss. This diagram shows the effective temperature reduction of a Swissbit module with a heat spreader against the same module without a heat spreader. The orange line shows the temperature curve by the self-heating of a module without a heat spreader. Depending on the test program phase with more or less traffic, the module heats up or cools down. The peaks are 5 to 8 degrees Celsius higher than with a heat spreader module. The heat spreader module is not always colder than the standard module, but it avoids the real high temperatures. You can see the slower heat up and cool down gradient due to the thermal mass that the heat spreader added to the module. The reduction of 5 degrees to the maximum temperature may be the difference between the pass or fail condition of the DRAM chips. The Swissbit heat spreader is constructed out of a thin aluminum plate which is connected to the DRAMs by a wide adhesive and thermally conductive special tape. The tape is also specified for the complete temperature range of the industrial memory module. The complete heat spreader with tape adds little less than 1.5 millimeters to the module thickness. The module still fits into the standard stacked SODIMM sockets. It is available for all standard height SODIMM and mini DIMM. Besides effectively increasing the reliability and operation range of the module, the heat spreader also looks great. Heavy industrial air, loaded with chloride or sulfuric gas or high humidity or dust, can damage any unprotected printed circuit board or solder connection. The thin copper lines corrode and either increase the electrical resistance or finally completely fail. Modules in heavy industry, sandy areas, or offshore operation are likely to see a reduced lifespan if nothing prevents them from being damaged. As a solution to this problem, Swissbit offers to protect the memory module with conformal coating. This is a thin polyurethane film that covers all surfaces except the gold connector area, which is already immune against corrosion. The coating material contains a fluorescent substance that allows visual control of the module coating completeness, a process step that Swissbit implemented to monitor the quality of the protective film. If your system board is already coated, then add Swissbit modules to complete the protection of your system.
Thank you for listening.